In this slide deck, I want to talk to you about troubleshooting. You won't find much of this content in the textbook for this course if you're taking Database Administration 2, for which I'm recording this video. But I wanted to talk about troubleshooting, this sort of the theory and some methodologies that you can use for troubleshooting. To me, troubleshooting sometimes it feels a little bit like writing an English paper, right? For some students and for some people who are newer in the industry, before you have a real methodology. Think about when something goes wrong, something's broken, and you have to figure out what's wrong with it. Some people just poke around trying to figure it out, right? And that method is really not effective in most cases. What's more effective is if you have some methodology and you have some steps that you take, that you follow, that help you determine what the problem is in a meaningful way. So I'm going to talk about a couple different ways to do that, but basically, there are some generic steps that we should always be taking when we're troubleshooting in the in IT systems. We always want to back up our data. We always want to divide and analyze, verify, research, document, and then inform. And I'm going to expand on these a little bit, but this is kind of a very generic version. But it's some more specific methodologies. So CompTIA has two methodologies I could talk about. One is the server plus model, which starts with identifying the problem and then establishing a theory of probable cause. Then you test the theory to determine its actual cause, and then you create a plan of action, implement a solution, verify the results, and then do a root cause analysis to see if there's some root problem that you haven't discovered yet. So those are the 7 basic steps in the Server Plus model. And the Network Plus model, and document a resolution. And the Network Plus model, also from CompTIA, has a whole bunch of these, right? In Network Plus, they say identify the exact issue, recreate the problem, isolate the cause, formulate a correction, implement the correction, test the solution, and repeat this as necessary, right? Formulate correction, implement, test, over and over again. And then you document the problem and the solution and provide feedback. Really, it's very similar to the other one, right? Except what I don't like about this one is it starts with identifying the exact issue, right? That's probably the hardest part in troubleshooting, and it's listed as the first thing, right? If I could do that, the rest of this is very easy, right? Novell has a model as well. So with Novell, they tell you to first try some quick, obvious fixes, right? Based on your experience and what you already know, try that stuff first. That's Novell's model. If that doesn't work, gather some basic information, develop some kind of a plan, execute your plan, verify the user is satisfied, and then document the solution. Again, I think this one's a little bit flawed in that, we're kind of back to just trying stuff in the beginning, right? And then developing a plan, how do I develop a plan, right? What exactly do I do? If I knew that, then again, I wouldn't need this methodology. So that's Novell's model. Novell is obviously, some of you probably don't even know who Novell is anymore, right? They've been slowly going away. But really, all of these different models that you see, right? Whether it's CompTIA or Oracle's model or, whoever, right? All these different models, they're all based around the ASID model, which is to acquire, simplify, implement, and document, right? ASID, acquire, simplify, implement, and document. Not to be confused with with ASID transactions that we talk about in databases, right? So this is a database class, so I know, we're using a similar term here, but with troubleshooting, when we talk about ASID, we're talking about acquire, simplify, implement, and document. So what do we mean by that? So under acquire, we are collecting information about the problem. So we're trying to get symptoms of the problem from the users. What error message did you see? Repeat, is it repeatable? Can I see it happen again, right? Can I see the same problem over and over again? That helps me identify what's causing it. Document the steps that it takes to cause the problem. Are there any recent changes to the system that could have, or the configuration maybe that could have caused this problem, right? So we always want to make sure that we're documenting any changes to our systems over time so that we can use that to help figure out if it caused an issue, right? And any error codes that the user sees. So hopefully we gather all of this stuff first. So the first step is acquire, get all of this information. Easier said than done, right? Eliciting symptoms of the problem is one of the hardest things, I think, for us to do with troubleshooting, because a lot of times the users are not very forthcoming. And sometimes, users don't understand that certain things are important, right? They miss certain things. So again, eliciting symptoms is very difficult. Think about when you go to the doctor, right? A couple things happen when we all go to the doctor. I think, we're not doctors, most of us, right? We're not medical professionals. So, a lot of times we're giving a lot of information to the doctor, much of which is irrelevant. And the doctor has to pick through that and understand that certain things are not relevant to the case, but other things are relevant. So a lot of times that's one of the hard things about eliciting symptoms is which things are actually relevant to this, to this issue, and which things really should have no bearing on this issue. And if you get that wrong sometimes, right, it can either take you down a rabbit hole, because you're investigating, a cause that really shouldn't have anything to do with the problem, or you think, well, that's not very important, but it turns out that that was actually the critical issue, right? So it takes a lot of experience to really be able to elicit those symptoms of the problem, and to really kind of understand what's salient about the issue. So that's the acquire phase. So after we're done acquiring, and there's some other specific tips here for hardware and stuff like that, but the next step in ASID is to simplify. So we're going to remove any non-critical components, remove anything that is not necessary to this problem, right? So we try to turn everything off, right? So think about basic troubleshooting for your car, right? If something's not working in your car, your mechanic might start to try to isolate the problem by or simplify the problem by removing everything that you don't need, right? So we're going to remove anything that's not critical. We're going to shut down anything that we don't absolutely need. Maybe we're going to, try to keep people from connecting to the database for a while so that we can, verify that that's not the issue, right? That it's not overworked or a resource problem or something like that, right? So we're going to try to simplify and get to the least common denominator. Next, once we do that, and by the way, part of that is to isolate components, right? So we're going to isolate our different subsystems. We're going to turn things off that we don't need. We try to get down to the most simplest configuration that can recreate the problem, and that's a really important. That's why I want to pause here. Is it's really important that you that's one of your goals in your troubleshooting steps. Is it's so much easier to figure things out when you get rid of all the variables, right? The fewer variables we have, it's like factoring, right? When you factor a math problem, the fewer variables we have to get to the simplest version of the problem, it's going to be much easier for us to find the root of the problem and to fix whatever's being causing the problem. One good example I have is, a lot of times people will fix problems in IT by throwing more resources at it, right? They'll say, well, we've got a lot of latency in database queries, so we're going to add more memory to the database server. We're going to convert to solid state disk, and maybe you do need to do those things, but in some cases I've seen people add those types of resources only to find out that, the problem is still there. It's just that we're masking it by adding a lot more resources to the problem, right? It's like if your car is having some issues, and instead of using better gas, you decide to put a new engine in, right? That's kind of overkill. Sure, it might fix the problem, but you could have done something simpler, right? I recently had that happen with my lawnmower. My lawnmower wasn't running right, and somebody told me replace the coil on it, which is a $200 part on a riding lawnmower, but it turned out it was just the gas cap. I just had a clog in the gas cap and it wasn't letting air in, right? So it was kind of dumb. It was a stupid problem. I fixed it for $5. So once we identify the problem, we're going to implement. So we're going to identify and implement potential solutions one at a time. It's really important to do one at a time. A lot of times we get into this mode where we're trying everything. We're throwing everything but the kitchen sink at the problem to try to see if it fixes it. But you have to be methodical about it. You have to try one thing. If that works, great. If it doesn't work, then you remove that thing and you try something else and you measure what happened, right? So you're observing what happens each time you try a different fix. Now, maybe the combination of several different things might solve the problem, right? But maybe it won't, right? Or maybe, and it's good to know, right? We want as much information, because let's say this problem happens again, and all we know is we did these 5 things and the problem went away. But maybe the real solution was only the 4th thing that you did. Now, every time you have this problem in the future, your experience is going to tell you have to do all 5 things, when really we only need to do one of those 5 things, the 4th thing. So it's important to implement these one at a time. You're going to check for potential solutions. You can use online documentation. There's certainly no shortage of online documentation for MariaDB. There are forums where people have tried a lot of this stuff. So you can go out and search the internet. You can look at the training materials. I find the documentation from MariaDB is excellent. I reference a lot in this course. I give you the links to some of the documentation and the knowledge base articles and so forth. But most importantly, document any changes that you make. Make sure that they are documented so that you know in the future. It helps us not only for our own recollection, but people in the future that are going to try to do something. One thing that's kind of annoying too is so many people have a problem and they never, like you ever go on these forums and people post that they have a problem and, you'll see people provide some potential solutions, but you never see that person come back and say, yep, this was the problem, right? So you don't know which of the 5 or 6 things somebody posted on there was the one that solved their problem, or if any of them solved their problem. Then the last step in ASID is to document. So this is you're going to do documentation throughout the entire process of troubleshooting, and it only finishes after you have a final resolution. And then during the other stages, you would have been documenting error symptoms, components that you removed, things that you tried to change, configuration changes that you made, things that were successful, were not successful, right? So you're going to have all of this information so at the end, you can fully understand what you did that fixed the problem, and you can save that as a reference for later on. So it's really important to do the documentation. This is a step I think that most people neglect in troubleshooting is they don't do the documentation. They're very focused on just getting it working, right? All right, sorry, I went the wrong way on my slide presentation here. As I said before, gathering user information from the user is one of the hardest things you have to do with troubleshooting, right? It's like pulling teeth out of some people to get information about what happened. But it is a necessary step in the troubleshooting, in all of these different troubleshooting models. So we have to identify and capture information about the environment, the error codes they might see, circumstances when the problem occurred, right? So it's the kind of things that we're trying to get from the user. And again, they're going to give us a lot of information that's not relevant, and one of our jobs is to try to understand what is relevant, right? To be able to see through all of, see through the forest, right? And see through all of this, information they're giving us to get to what is salient about the issue. So some of the information resources, you have documentation, forums online. There's other resources like magazines, trade magazines, although that's kind of a dated one. But there's a lot of resources online. There are blogs and things about databases that have lots of good information, websites, other employees where you work, news groups, trade shows, vendor group meetings, open source forums and things like that. Independent consultants can help. One of the challenges with something like MariaDB is there is no company, right? MariaDB is not a corporation that we can call up and say, I need support, right? There's nobody standing behind that product. And a lot of our modern, a lot of the modern systems we use in IT now are like that, right? Linux is, you could go and hire Red Hat, but, nobody really has a warranty on a lot of this open source stuff, right? It's not like you can call Microsoft and Microsoft is accountable to the software that they create and the systems that they sell. Even the other vendors like Dell and HP and so forth, and EMC for storage and all that stuff. So again, independent consultants can work as well. Somebody who's a subject matter expert in certain areas and some of the software that can help you identify and correct these problems or help you through particularly tough issues. As far as tracking options, what we commonly call a help desk, right? I mean, you've got some really simple options for tracking issues and problems. It could be pen and paper or a 3-ring binder, right? But you'll quickly outgrow that in most organizations. So there are some off-the-shelf problem tracking and resolution database systems. It is important to have some mechanism and some system that you can use when you have a live production system that you can track user complaints and you can track the resolution of those complaints, and you have a place to go to have some accountability to how these problems are solved, right? And also to track them, right? Somebody calls and says, I have a problem. You say, I'll work on it later. You forget about it. And a month later, they say, hey, this problem still isn't solved, right? That doesn't really help anyone. So we want to make sure we have some way to make sure that these things don't fall through the cracks. So having some tracking system in place to do that is great. Many organizations already have problem tracking systems, right? They have a help desk system or, some process or procedure around that we can, that we could also use in the realm of database support. But if not, right, if that mechanism doesn't exist or if it's not something that you can leverage in your database support, then you have to come up with something to do that. Now, as luck has it, as database people, Tracking systems, I think, are kind of very at home for database people, right? So a lot of us can custom build an application that can do that, right? So that's those are some tracking options. Some recommendations around tracking systems. They should have the username and location, the operating system or hardware platform that they're using, the date that the call was received or the issue was created, when the user was contacted, how much time was spent on the problem is important. It helps your utilization of solving these problems. How many people do I need to support this database, right? The date that the problem was resolved, how long was it open, a detailed description of the problem so people can go back later and use that as an information resource, detailed descriptions and steps that were used to resolve the problem in case, say, again, if it comes up again, a summary of the problem, again, to make it easier, we want this metadata that can be searched, and of course the resolution. There are off-the-shelf software that you can purchase to do a lot of this stuff that I talked about for problem tracking. There's no shortage of vendors out there in the market that have software to manage problems. Help desk software. IBM has a very expensive system that you can buy to do this, but it's also kind of one of the best systems out there, right? But you get, I guess, that stuff costs a lot when you buy it from a big company like IBM, Computer Associates. There's a whole bunch of companies out there. I mean, I just brainstorm two simple ones here, but there are a lot of smaller companies that have great products. There are open source products that you can use. There are, you could build your own if you want. There's all kinds of options for some kind of help desk software to track issues and make sure that they're resolved. As a DBA, though, I think I can't understate that, one of the responsibilities of a database administrator is to have some mechanism to track all this stuff and to make sure that we're solving issues as quickly as possible and that we're being held accountable to those resolutions. So that's it. So in this unit, I talked about logging, and I also talked about troubleshooting methodologies. And then following this unit, we have our midterm exam, which I'll post a video that discusses that in the next unit. Thank you.